So let's find the limit as both x and y approach 0 of the function x squared y cubed over 2x squared plus y squared. Now, clearly both of these are polynomials in two variables. So I know that this function, which I'm going to, let's just call it f of x, y. So I know that f of x, y is continuous for all x, y in R such that 2x squared plus y squared is not equal to 0. Well, that is only going to happen when both x and y are 0. So that's one reason, I suppose, why we're interested specifically in this limit. So I know right away that it's going to be discontinuous because I have something that's undefined at 0, 0. However, does a limit exist? So let's take a look at a couple of possibilities here. I'm going to call this, say, case number 1. In case number 1, I'm going to say y is greater than 0. Now, what I'm seeing here is that x squared and y squared, for any value of x and y, this component is always going to be positive. But if y is negative, then this component is going to be negative. If y is positive, so this component is going to be positive. So I'm starting off specifying y is positive, and then I'll take a look at case 2, basically, so when y is negative. So when y is positive, what I'm seeing here is that it must be true that 0 is less than or equal to x squared y cubed over 2x squared plus y squared. And it doesn't matter if x is positive or negative because it's squared, so it's always positive. But that has got to actually be less than or equal to y cubed. And the reason I say that is take a look at the rest of that. X squared over 2x squared plus y squared. The denominator is going to be bigger than the numerator, so this ratio is going to be less than 1. So if it's less than 1, I'm multiplying this component y cubed by something less than 1. So this is a true statement. What that means is the limit as, say, xy goes to 0, obviously of 0, is less than or equal to the limit as xy goes to, I'm sorry, that should be 0, 0, of x squared y cubed over 2x squared plus y squared, which is less than or equal to the limit as xy goes to 0, 0 of y cubed. Well, clearly this limit is 0. This is a limit that we're curious about. And this limit clearly goes to 0. Therefore, by the squeeze theorem, the limit as x and y go to 0 of f of xy is also equal to 0. So the limit is 0, but we're undefined at 0. So that's telling me basically that I'm going to have a hole when I get there. Now, actually, I jumped the gun a little bit with this last statement right here. This is really only for case 1, and I really need to consider case 2. But for case number 2, I'm simply going to have y is less than 0. So now all I'm going to have is y cubed is less than or equal to x squared y cubed over 2x squared plus y squared, which is less than or equal to 0. And again, I take the limits, I get the exact same thing. And then, like I said, I did kind of jump the gun a little bit. Then I can say, by the squeeze theorem, this limit is actually 0. See, this is true specifically for y greater than 0, and then I showed it again for y less than 0, so I have my bases covered.